For centuries, humanity has gazed up at the moon, wondering what secrets it hides. While its familiar face has been mapped and studied in detail, its far side and lunar south pole remain shrouded in mystery. This region, bathed in permanent shadow in some craters and touched by sunlight at the peaks, is one of the most scientifically intriguing and strategically important places in the entire solar system. Today, the moon's south pole has become a prime target for NASA and international space agencies and private companies, as it may hold the key to unlocking both the origins of the solar system and the future of human exploration beyond Earth. Why the south pole of the moon is so unique, unlike most of the moon's surface. The South Pole contains areas that have remained in permanent shadow for billions of years. These regions, called permanently shadowed regions (PSRS), never receive direct sunlight, leaving them as frozen time capsules of cosmic history. Temperatures in these craters plunge below -230 degrees Celsius, colder than even Pluto's surface. Scientists believe that within this eternal cold lies one of the most valuable resources for exploration: water ice. The discovery of water molecules at the lunar South Pole, confirmed by missions like India's Chandrayaan-1 and NASA's Lunar Reconnaissance Orbiter, revolutionized our understanding of the moon. This isn't just a scientific curiosity, water. Ice could be used to sustain astronauts, grow food, and even be split into hydrogen and oxygen for rocket fuel, transforming the moon into a refueling station for missions to Mars and beyond. A record of solar system history beyond resources, the South Pole holds enormous scientific value. The South Poleitkin Basin, one of the largest and oldest impact craters in the solar system, stretches nearly 2,500 kilometers across and dives 8 kilometers deep. This gigantic scar is thought to expose material from the moon's mantle, offering clues about the internal structure of rocky planets. Studying it could help scientists answer fundamental questions. How did the moon and Earth form after the giant impact that created them? What was the rate and scale of asteroid bombardments in the early solar system? Could ancient water or organic compounds have been delivered to Earth by comets, seeding the conditions for life? In this sense, the lunar South Pole acts as a time capsule, preserving billions of years of cosmic history in its rocks, regolith, and icy deposits. Why space agencies are racing to the lunar South Pole? It's no surprise that the South Pole of the moon has become the focal point of modern space exploration. NASA's Artemis program aims to land astronauts at the South Pole by the middle of this decade, marking humanity's first return to the moon since Apollo 17 in 1972. Unlike the Apollo missions, Artemis isn't just about footprints. It's about building a long-term presence on the moon. The European Space Agency, ESA, Russia, China, and even private companies are also developing missions to explore this region. China's Change-4 has already landed on the far side of the moon, paving the way for future missions targeting the South Pole. Meanwhile, robotic landers and rovers will scout the terrain, study the permanently shadowed craters, and search for water ice deposits that can support human outposts. The race to the lunar South Pole is more than a scientific endeavor. It's a strategic and geopolitical contest. Whoever learns to use lunar resources first could gain a significant advantage. In the coming age of space colonization and interplanetary travel, water ice, the gold of the moon. One of the greatest mysteries of the lunar South Pole is just how much water ice is trapped in its permanently shadowed craters. Some estimates suggest hundreds of millions of tons could exist locked in the soil. If true, this discovery changes everything. Water is heavy and expensive to launch from Earth. Having access to lunar water would allow astronauts to drink, grow plants, and produce oxygen for breathing. Even more importantly, splitting water into hydrogen and oxygen creates rocket fuel, turning the moon into a cosmic gas station. This resource could lower the cost of space missions dramatically, enabling sustainable exploration of Mars, asteroids, and beyond. A laboratory for cosmic science, the Moon's South Pole isn't just about resources. It's also a natural observatory. Because of its permanent darkness and radio silence from Earth, certain craters could host telescopes that peer deep into the cosmos without interference. These observatories could capture faint signals from the early universe, helping scientists study the formation of the first galaxies, stars, and black holes. Additionally, rocks and soil samples from the South Pole may preserve records of cosmic rays and solar wind particles that date back billions of years. This data could help astronomers reconstruct the history of solar activity and understand how radiation has shaped planetary environments across the solar system, connecting the moon's past to Earth's future. Studying the South Pole isn't just about the moon, it's about Earth too. By unlocking the moon's history, scientists gain insights into how our own planet formed, how water arrived here, and how conditions for life may have developed. The moon acts as a mirror of Earth's past, allowing us to peer back in time in ways we cannot achieve on Earth itself, where geology and weather erase ancient evidence. At the same time, the South Pole offers a gateway to our future in space. By establishing sustainable human presence on the moon, we prepare for the day when humanity will become a multiplanetary species. Living and working beyond Earth, the intrigue of exploration, the allure of the South Pole lies in its dual role. It is both a scientific treasure chest and a practical resource hub. It promises answers to some of the deepest questions in science about the origins of Earth, the solar system, and life, while also offering the tangible resources we need to take our next giant leap. Exploring the South Pole is not without challenges. The extreme cold, permanent shadows, and rugged terrain make it one of the harshest environments in the solar system. But with advanced robotics, autonomous systems, and innovative technology, humans are closer than ever to unveiling its secrets. Conclusion: the moon's South Pole as humanity's next frontier. The moon's South Pole is more than just another place in space. It is a cosmic frontier of science, mystery, and opportunity. From the ancient South Pole lichen basin to the hidden reserves of water ice, this region holds the keys to both our past and our future. In the coming years, as Artemis astronauts set foot in this untouched landscape, humanity will open a new chapter in exploration. What we find there will not only rewrite textbooks about the moon and solar system, but also pave the way for our journey to Mars and beyond. The South Pole of the moon reminds us that even the most familiar object in our night sky still holds mysteries waiting to be uncovered. It is a reminder that the story of exploration is far from over. In fact, it is only just beginning.